Hey everybody, this is Larry. This is day 17 of the Leetcode Daily Challenge. Hit the like button and subscribe button, join me in Discord. Let me know what you think about this one. Another medium problem. With 34-7, find the largest area of square inside two rectangles. Yeah, hit the like button and subscribe button, join me in Discord. Let me know what you think about this one. Yeah, I don't know why I'm so tired these days. I haven't even been exercising that much. Well, I mean, I guess I went to the gym today and I did some deadlifts and I ran a couple of miles, but not that much. So I don't know. Tomorrow I'm trying to like ramp up for a bit more miles, but it's just been so cold here in New York. But you know, a grind is a grind because it's a grind. So yeah, let's take a look at today's problem. Hopefully it's simple, and then we can just call it a night. Yeah. Let's see, we have 34-7. Find the largest area of square inside two rectangles. I'm going to read this silently as I drink this water, so you know my voice by now. Just you know, imagine me reading it. Maximum area of a square that can fit inside the intersecting region of at least two rectangles. Huh. I mean, everything's axis aligned, so that's one. But excuse me, I'm still coughing like a crazy maniac. But 1, 1, 2, 5, 5. N is equal to 1,000 is actually interesting. I was thinking more sweep line. I mean, this is definitely a tricky one. I'm thinking, and still am thinking about more like a sweep line type algorithm, but N is equal to 1,000 is interesting because then it opens up N square solutions. And I'm trying to think what N square solution could be. The thing that tricks me a little bit is that wait, maybe I misread this one actually. Actually, maybe it's fine. Maybe it's just an N square type intersection thing. I think I misread this example because for this one I thought that there's a 2x2 square such that actually maybe no, I think that's right. I think this wording is so awkward because but it does mean that there's this square that is intersecting, or half of it is inside the bottom half, the bottom square. No, wait, no, that's link 4. That's not link 5. Okay. Okay, I see. Never mind. I think I misread this. Well, I misread this example because I thought that you have a square here, you have a square here, and then you have a square here. Then now the middle square. So I would have think if my interpretation is correct there, then actually the answer would be 16. But the answer is 4 because you just take two squares and then intersect them. So in that sense, then my initial interpretation is more correct, which is that you know, you have 1,000 squares only. N square is fine, so let's just force N square and for the answer, right? For the maximum intersection between them, right? So yeah, so maybe I don't know, something like this, right? I actually just had very spicy food, so so I'm like drinking a lot of water as a result. So excuse me. But yeah. And then now you have two rectangles, and you're trying to figure out the intersection area. And not just the intersection area, but the biggest square that could fit into it. I'm trying to think what's the standard way of doing it. I need pen and paper somewhere, probably. But okay. Okay. I think the first thing, actually, I do have some ideas. The first idea would be that you kind of always think about these rectangles. It's going to be a little bit tricky, right? So actually, the idea actually is to break it down one dimension at a time. Maybe that's the key takeaway for this one, right? Because then now, if you take it one dimension at a time, then you could just do segment overlap math, and that at least for me, I know that more familiarly. Where the 2D one, I probably do know it, but I have to but definitely not as well, and I have to start from scratch kind of thing, right? But if I was able to, if I was able to do it dimension by dimension, then it just becomes two segments. Two segments, try to figure out the overlap, and then two segments overlap, right? So let's do it that way. Yeah, let's do it that way. Yeah, okay. So then you have bottom left, so AXAY is equal to okay, so something like this maybe, right? And then now right, and then now we can just do overlap x is equal to, I don't know, calculate the overlap from AXBX CX dx, and then overlap y is equal to overlap AYBY CY dy, and then the area of a rectangle of a square is just this squared, right? So then now we need overlap, right? So we have how did I usually I don't know. I'm trying to think about how did a y get in there? Okay, so AXBX is one number, right? So we have min. This part I feel like I'm doing it pseudo autopilot, but I'm not quite sure. Actually, is it min? No, it's max. And then this is assuming that bx is greater than ax and dx is bigger than by, possibly. Oh wait, no. Just that ax is this, and then cx is less than this, right? So then now bx dx, right? So that would be the overlap. The length of the overlap is just the difference between these, right? And then we have to, just make sure that this is at least 0. So something like that. Hopefully that's right. I thought I could do that. I thought I could write it that way. I always forget how to write. I always this unrolling and stuff like that is always I always forget how to do it precisely. It looks okay. Let's give it YOLO submit. Might be wrong, but I'm just gonna give it submit anyway. Okay. So yeah, I think the key part to this problem is, well, one is noticing that n is 1,000, right? So 1,000 makes it easier to do n squared, or even possible. Because if you didn't think it was possible, you wouldn't think of n squared strategies, right? For obvious reasons. And that's why I always look at constraint. That's part one. And then this part, the key thing is to separate out the dimensions. And once you realize that they can be independent, then it just becomes much easier. And this is, I want to say a little bit of autopilot, but you can actually draw out the cases, right? It's just to draw out the lines. If you have 2 lines, then you're limited by, you just try to figure out where the limiters are, and that's basically it. Yeah, that's it. That's what I have for this one. This is n squared because of this, and everything else is over 1, so we're pretty happy-ish. I don't know. But yeah. Alright, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.